The next speaker is Dr. Stephen Cadavid. He's the president and founder of a company called KinaTrax. They are involved in basically developing markerless motion capture systems. And some of the earliest applications they have is in sports, like in analyzing motions of pictures, basketball players. So since Warriors are playing tonight, I'm very interested in the application of this technology in sports. Steve has been involved for most of his career in developing biometric recognition and markerless capture systems, and he has authored more than 20 papers. Stephen?
Well, thanks. My name is Stephen Cadavid, and I'm the president at KinaTrax. So today I'm going to give a presentation. Typically I would give something a bit more technical, but I want to keep it light and fun here and discuss our baseball system and how you can apply computer vision to baseball. We came up with this title with Jeff Beer. I think it's a little strong. The word win, we don't win baseball games. The players win baseball games, but we do provide a competitive advantage, we think so, to the teams so that they can make decisions regarding how to prevent injury for their pitchers, as well as to improve the mechanics of the pitchers and their performance as a result. So a lot of people like to know, how does a computer vision guy get into the baseball field? So it's an interesting story. I'll start off with it. One of our co-founders essentially is an avid baseball fan. For many years, he had season tickets for the Philadelphia Phillies, and he was invited to many different events with the Phillies. And one day he sat down with an executive there, and that they started talking, and essentially, the co-founder asked, what would be the pinnacle of computation or having some sort of analytics for pitchers in a game? And the executive said, if you could have something like motion capture that is captured within a lab, but in game, and do that for our pitchers, that would be the pinnacle. And there was a period of time in the early 2000s, I don't know if some of you may have seen the movie Moneyball, where the Oakland A's essentially, during the 2002 and 2003 seasons, they had a limited budget for their players around $40 million. That pales in comparison to the New York Yankees, who has something like $150 million on their payroll. But during the 2002-2003 seasons, they were able to actually make a playoff run, pretty deep playoff runs during those seasons with this very limited payroll. And what they used was what's known as sabermetrics. So conventional player metrics were used to make decisions on quote-unquote diamond in the rough players. And that really inspired the work that is happening now, which is called the post-Moneyball era, where more and more technologies, in particular computer vision technologies, are being applied to baseball to be able to extract advanced metrics on pitchers. So Jeff Passan, Yahoo Sports columnist, last year came out with a great book called The Arm, the most valuable commodity in sports. And that book is really interesting, and the baseball pitcher's arm is truly the most valuable commodity in sports. So every year, MLB spends more than $1.5 billion on its pitchers. That's 5 times the combined salaries of all the starting quarterbacks in the NFL. That's one stat. Another one is that is more than the top 200 combined salaries in the NBA, of the top 200 highest paid players in the NBA. So there is definitely a lot of money and a lot of value in that arm, okay? And remarkably, there's relatively little that has been done in terms of technology to try to prevent injury and try to maximize the potential of the players. There's a lot of these old baseball guys who essentially are kind of looking at video, 2D video, and just making kind of qualitative assessments. So we're coming along and trying to put a quantitative spin on this. Let's look at the top few pitchers in the MLB, and these salaries are ever increasing. So top pitcher in terms of salary is Clayton Kershaw, star pitcher for the Dodgers. and you have grind key. So all of these 2017 salaries are in the 20 and $30 million. With that great amount of value there is, pitchers are facing a major epidemic, and that is they're tearing their ulnar collateral ligament. So the ulnar collateral ligament is a tiny ligament that connects your upper arm to your lower arm. And it's really a 12-inch ligament by 2 inches. And if that snaps, that could potentially ruin a baseball career. So we're seeing this trend over the years, in particular in recent years. Starting in 2012, there was a major spike in the number of MLB pitchers that required this Tommy John surgery. And there's a correlation, courtesy of Fangraphs, that shows some analyses that have been done on the pitch speed, the velocity, and the number of pitchers within that sample that required Tommy John surgery. So as you can see, pitchers that are above 90 miles per hour in their pitch are requiring a significant number of those pitchers are requiring Tommy John surgery. So what can we do to prevent this UCL damage and to the pitchers and try to keep them out on the field? Well, the traditional way of doing that is to bring in a pitcher, typically after they've been injured, into a lab. The most famous lab, almost all the pitchers go to this lab. It's called the ASMI, American Sports Medicine Institute. And they basically suit up the individual with a series of markers, these reflective markers, and this is typically called marker-based motion capture. So essentially, it's an optical camera array, and you're triangulating each one of these reflective markers, and then you obtain a 3D position for each one of those landmarks, and then you're able to obtain the kinematic chain, or the skeleton of that individual on a frame-by-frame basis. The disadvantage to this system is a couple. First one being, in an outdoor environment, it is possible outdoor, but individuals are, the pitchers are sweaty, they're pitching. These are sticker-based, adhesive-based markers, so essentially they come off. And secondly, you have soft tissue. So the arm, the lower flap here of the arm, that moves all over the place. If you look at the videos of a pitcher throwing, you'll notice that this soft tissue is all over the place. And although marker-based mocap is considered a gold standard, it does have its disadvantages in terms of accuracy in tracking that soft tissue, which is so critical to understanding the mechanics. But once you get this biomechanical data, you're then able to potentially translate that onto the field through a coach. Coach could look at that kinematic data via biomechanical software and then determine what's wrong with the mechanics, if there's an arm slot issue, and apply that. So even though the marker-based motion capture is the gold standard, it has there's advantages to doing markerless. So in the markerless, basically you have an in-game capability because you don't have to wear sensors, and there's the potential of doing it there. And then in the game, you have physiological characteristics that are not present in a lab setting. So, for example, adrenaline fatigue, you would only have that in an in-game setting. So the pinnacle of motion capture analysis would be to be able to collect biomechanical data within the game. So in 2013, KinaTrax set out to do that. And KinaTrax is basically consists of multiple cameras mounted throughout the seating area of the stadium. They're all oriented towards the pitcher's mound and capturing high-speed synchronous video of the pitcher. And from that, we're able to obtain a 3D reconstruction of the pitcher on a frame-by-frame basis and extract the kinematic data. There are a variety of what I call the computer vision revolution as part of this post-Moneyball era that is using vision-based algorithms. They're at a macro level. So one technology is called StatCast. MLB has a media arm called MLBAM, And recently they developed a technology called the StatCast. It tracks the center of mass of the players on the field in real time. And this came out relatively recently in the past 5 years. And that has really brought an influx, a massive amount of data that statisticians and the mathematicians on the teams are analyzing. But that really just gives you a center of mass information. The second type of technology is PitchFX, developed by SportVision. And what that does is track the trajectory of the ball from the pitcher's hand to the batter's box. So, and then the third technology is TrackMan, which is in this lower left-hand corner, which tracks the trajectory of the ball as it leaves the bat. So we have here macro level tracking of the center of mass of the pitcher. We have the pitch trajectory tracking, and we have the trajectory of the ball as it leaves the stadium. So KinaTrax, what the value add here for the teams is that we're able to do this micro level analysis of the biomechanics at the mound. So we're tracking 20 plus joints on the body on a frame by frame basis at over 300 frames per second. So here's a layout of the camera configuration at the stadium. So we have multiple cameras mounted in the concourse area. These are all 10 gig fiber cameras that run back to a centralized server in a rack room. And we have a full rack full of computers that are doing the heavy lifting on the computer vision side. Then 12 to 24 hours after the game, the teams then receive the motion capture results for every pitch that takes place during that previous game. So over the course of the 2016 season, we processed the biomechanics of over 60,000 MLB pitches, and that actually translates to over 6 million frames that we did pose estimation for. Our algorithms are relatively slow. We're not an embedded application by any means. Our clients require a very high level of accuracy. So we care more about accuracy rather than speed. And we do a fairly good job. So 95% of our frames are within a 5-degree angular error. We tested that across elbow flexion, which is extension and flexion, as well as shoulder internal, external rotation. So that is very important measures for understanding the mechanics of a pitch. So here is an example of our results. This was captured at Citi Field. So funny story here, back in, I want to say 2015. Our first installation was at the Tampa Bay Rays at Tropicana Field in 2016. They were the first team to adopt the technology, but in 2015, we were given 1 day to set up 8 cameras at the stadium. Actually, not 1 day, we were given like 3 hours to set up these cameras because they were gonna have a minor league bullpen session. And we had to run around with tripods, 3 of us, set them up, get the system working, capture data, because that was the only time they were gonna slot that they were gonna give us the ability to capture in-game data. So we wanted to do this at a Major League ballpark too, just as a proof of concept. And we were able to collect this data. So this is one of those pilot pitches that we used for the initial proof of concept. It was quite a process to convince the teams that this could work reliably on a pitch-by-pitch basis, but based on this result, we were able to get traction. And then over the course of the 2015, the Rays were happy with the result they got, and that quickly got us 2 additional teams, one of them being the Chicago Cubs. So that's from one viewpoint. This is from a second viewpoint of the same pitch. This is a minor leaguer. So we compute the kinematics for both home and visiting team pitches. There's a lot of implications here from a competitive advantage standpoint. If you're looking at the visiting team mechanics, then you can determine for trades and acquisition purposes which pitcher you want to acquire from another team. You can also monitor fatigue within the game, so you can make changes on your hitting lineup based on whether or not a pitcher is looking fatigued during the game. Even though this is a completely offline algorithm, you can look after the fact and determine different factors that could potentially play a role. And then you can start looking at things like, because I mentioned within a lab, typically you collect data after an injury takes place. You don't have what we call prospective data or pre-injury, substantial amount of pre-injury data. You have no way to compare pre-injury mechanics versus post-injury and know when a pitcher should come back into the lineup. But in the KinaTrax system, we have literally thousands of pitches pre-injury, and we can compare that to a ton of data post-injury, and then we can make decisions. One interesting use case we had last season was a undisclosed pitcher essentially tweaked his back in a game. We had a ton of pre-injury data for him, and he then went out of rehab, and he said he was ready to go back in. Simulated game, he then pitched a simulated game. He was ready to go back into the lineup. He said he felt great. We looked at the simulated game data, compared that to his pre-injury data, and there were clear differences in his lower extremity mechanics that the KinaTrax data picked up on. But you know what? He felt great. Coach said, okay, we'll bring you in. So he had a minor league start, and we saw that the mechanics, he had a terrible outing. Okay, yeah. And then we looked at the mechanics during that game, and they were much more consistent with post-injury data versus pre-injury when he was fine. So that was one example where we were able to pick up in the differences there post-injury versus pre-injury, and that teams can make decisions based on that data. So how does the system work? So we select a series of key poses within the pitch delivery, a wind up during the stretch, maximum external shoulder rotation, ball release, maximum internal shoulder rotation, follow through, and build these subject-specific models. That requires a lot of manual annotation that needs to be very accurate, because that underlying model that we build for that pitcher is going to translate to what every subsequent pitches for that individual. So we needed a partner to build these very precise models, and we vetted many different companies. And the company that we selected was iMerit. And iMerit, what they do is, it's been a fantastic relationship with them. We essentially provide a series of pitchers that require new models on a day-by-day basis, game-by-game basis. For example, tonight the Cubs will play. The Cubs will play. And basically at the end of the game, iMerit will go into the server and select a series of exemplar pitches for the pitchers we don't have a model for in our database. Then they will extract that data, do the manual annotations, build this underlying skeleton as well as this visual hall of the subject. And what is the output is a rigged visual hall that is then applied to the pitch data to get an output result. So those models are built and driven by, that whole workflow is driven by iMerit. So we're very thankful for that. So in 2016 was really our first major year in production. We were able to build 300 models for these 300 pitchers, spanning the majority of Major League Baseball. And now we're expanding out to minor league, where it's even more important because the mechanics there need more refinement and potentially more value add at the minor league level. So what are the kind of insights you can get from this data? I touched on a few, but one concrete example is the the internal external rotation at the shoulder, very important variable in understanding the consistency of a pitcher and their value. Here we have pitcher X for a given game. This was for a Rays game. 8 innings pitched, 98 pitches, 3 earned runs. And then we have for that same game pitcher Y. And these are 2 starting pitchers. They did 6.2 innings pitched, 98 pitches, 5 earned runs. And you can see the gray area, the shade is there's the variance on that shoulder abduction, adduction for the first 10 pitches versus the last 10 pitches for that pitcher on that particular game. And you can see that the variation is tighter on pitcher Y than it is for pitcher X. And pitcher X is paid a lot more than pitcher Y. So you can make decisions like that based on this kind of data. So just give you some idea of the details of our company. We have a very small company. It's 4 full-time individuals now. I'm the primary software developer there and machine learning guy. And then we have people on the data analysis side. We have this recurring revenue model where essentially teams pay on a yearly basis for us to be able to produce this result. KinaTrax has a substantial hands-on approach throughout the process, from pulling the pitches, building these models through iMerit, and then running the algorithms to process the results. And then we also provide some interpretation consulting services so that they can make sense of what this data means, because this is completely novel technology for these teams. They may not have a biomechanists on site, so we will provide some of those services for interpreting what these results mean and how they can make some value out of the data. So future plans is to expand. Right now we're at 3 major league ballparks and soon to be at 4 minor league sites. And we're looking to expand to all of Major League Baseball and then track the hitter, which is equally as interesting for many of the teams. And lastly, again, we did not help them win the World Series, but we did provide data that provided them some insights that I think were valuable to them. So that was a nice success story last year. Well, thanks so much.
Thank you, Stephen. Questions for Stephen? I mean, one obvious question I have is that since you guys already had the cameras installed, it does take you guys offline to analyze all this data. Any thoughts on going from offline to more real time so you can provide performance measures, like, for example, is the pitcher losing his pitch release point, for example, so that the coaches can make the adjustments in game?
Yeah, if we had a real-time result, that would open up a whole new series of applications. We're not there yet, but we hope to be there. Primarily, our goal is to have very accurate data. That's what's demanded by our client. Yeah. But real-time would be, as you said, you can monitor pitchers in game, make strategic decisions on when to pull a pitcher, etc.
Yeah. So it seems your camera in the setup is very far from the player, right? So can you disclose the camera optics resolution, frame rate, and do you need a calibration? Is fixed lens, fixed focus lens camera, or
they're variable focal length, zoom lenses.
Zoom lenses. Okay.
Yeah, they're expensive lenses.
I see.
Frame rate is 300 frames per second. The minimum you can have sampling rate-wise for Major League Baseball pitchers is 240 frames per second, or you would get, it's just not enough of a sampling rate to be able to analyze a pitch. So requires at least 240 frames per second.
Do you need calibrations between the cameras?
Yeah, we do, calibration of the cameras, obtain 3D geometry of the cameras. We deal with scenarios like all types of crazy challenges like vibration because of the crowd, and sometimes one camera drifts more if there's more of a crowd on one side of the stadium versus the other. That poses all kinds of challenges for our calibration.
But they're all offline processing.
Yeah, and then the lighting variation to cloud cover, we were able to handle it fairly well.
Thanks.
Stephen, great talk.
Thanks.
Just wondering, how do you deal with like shadows and like maybe, I know inclement weather is probably not a huge deal because they'll pause the game, but you know, like this, don't you have to deal with these kind of image impediments?
Yeah, capture a ton of backgrounds to represent the background versus foreground. And then if you think about it, if you use like a space carving approach, if you have one that's parallel, optical axis parallel to the mound, you can carve out that shadow. So we do need tricks like that. Like we can carve out the shadow from the visual hull.
Okay.
Yeah.
One more.
I'm from Dallas, and the Rangers could use a lot of help this year, so.
They're interested.
So I had a couple of things. So you're just tracking the skeleton, and I wonder if, you know, like you said, all the soft tissue here is wobbling around. Does that matter to these guys? Or?
Yeah, so pronation, supination is a major issue because there's no texture.
Yeah.
So some teams are actually willing, so nearby teams are willing to put potentially texture on the forearm on some of their pitchers to track.
No, tattoos.
Yeah, exactly. But yeah, the soft tissue, I would not heavily rely on pronation, supination on our data yet.
Yeah, okay. And you said you had a model like per pitcher, but it seems like it might matter what they're throwing, a fastball or a curveball or something like. Do you have to have multiple models for?
It's a local optimizer, so our single model, it's a good question. I mean, our single model right now is what's feasible from a budget perspective, but maybe we have to have a series of pitch types per pitcher. But it does a fairly good job at conforming as long as that one pitch is relatively close to the given frame we're trying to register to.
Last question. Use neural networks at all?
Excuse me?
Do you use neural networks at all?
Right now, it's more of a computational geometry problem, but we're heading in that direction once we have enough data. It's a data bottleneck right now.
Great. Okay, thank you. Great talk.